Having mastered array list, we will move on to learn the use of sets. Here is a problem statement. A bookstore contains a collection of books. A book has an ISBN number, a title, and author. This bookstore wants to maintain only unique books in the collection. So the collection should not accept a book object if it is already there in it. Also, fetching a book based on its properties should be efficient. Implement a class that handles this scenario. Test using a test class. Let us first define a book class. Let's define instance variables for ISBN, title, and author. Now let's define a class bookstore that will hold the collection of book objects. The requirement states that we need to maintain non-duplicate books, and fetching based on the fields should be efficient. So we need a set in this case. Java API provides an interface set. HashSet is an implementation of the set interface. The best collection to be used in this case is a HashSet. We are defining a HashSet named bookset. It is initialized in the constructor. There is a method to add a book to the store, which accepts a book object and calls the add method of HashSet. There is also a remove book from store method that accepts a book object and removes the book from the set. Then there is a method that simply returns the collection of books. We have defined a test class for testing our bookstore. We first create an object of the bookstore class. Then we create a few book objects and add them to the bookstore by calling addBookToStore method of bookstore class. In the end, we will display all the books in the store by calling getBooksFromStore. If you notice, we have some duplicate books being added. Book 1 and Book 4 have exactly same fields. So do Book 2 and Book 5. You should guess that these will not be added to the set as HashSet helps us avoid duplicates. Let's run the test class. Oops! We can see some weird things being printed and not the real values in book objects. Can you guess why? Well, yes, we did forget to overwrite the toString method in the string class. So it's using the object's class default implementation. Okay, let's do that now. It's easy. Just right-click, select source, and generate toString. Let's run it again. What's the output? The books collection does have duplicate books, although we used a HashSet. Any guesses? Well, the same mistake we make every time. How does the HashSet know if two book objects are indeed equal? Yes, we need to override equals. Let's do that as we did earlier in the ArrayList exercise. Now, when we run the program, it has indeed avoid duplicates. So the HashSet indeed works. Only thing is, while putting an object in a HashSet, we should ensure that the object does override the hash code and equals method. Why hash code? Well, that is what a HashSet uses to identify the bucket where the object should go, and that is what makes the retrieval of objects from a HashSet faster. We already learned this. A hash function computes an integer hash code from an object so that different objects are likely to have different hash codes. The objects that are equal should have the same hash code so that only one such object gets into the set. That is only possible when we override the hash code method. Eclipse has implemented an algorithm that helps quickly generate a hash code using the object's instance variables. So, we learned the creation of HashSet, adding and removing elements, and overriding equals and hashcode methods.